Okay, so we are going to learn a trick, and this is, I guess you could say, the first trick or the first significant trick to find inverse Laplace transforms that we couldn't before. So, right, we have this rule that the Laplace transform of the inverse Laplace transform of f of s over s is the integral of little f, where little f is the inverse Laplace transform of big F. So, in other words, if you know the inverse Laplace transform of big F, then this tells you what the Laplace transform of that over s would be. And there's a justification in the book. Really, this is just, we already learned how to do the Laplace transform of a derivative. This is really just restating the same thing. Because if I did the Laplace transform of this and I multiplied it by s, because the derivative of this is the Laplace transform of that, then I'm not explaining this well, but this is the same rule that we already learned in reverse. Just doing antiderivatives instead of derivatives, and using this rule. When I do the Laplace transform of a derivative, that multiplies it by s. So roughly speaking, when I do the antiderivative, I should divide it by s. Anyway, we can now do the inverse Laplace transform of something like this, which I guess actually we could already. We would just do partial fractions, but now I can do this without partial fractions. So how does this go? First, I find the Laplace transform of this, meaning like the s on the bottom is gone. And we know what that is. I'm starting to remember my Laplace transforms now, so I just knocked it out, but just to show everybody, that's this. A was -5, so I wrote e to the at. Yeah. So now, the Laplace transform I really want which is dividing the previous one by s, should be the following. It's the integral from 0 to t f of tau d tau, so 3e to the -5 tau d tau. So this letter tau is just a dummy variable. I'm going to do the antiderivative with respect to tau, and then because this is an integral from 0 to t, in the end I'll plug in t. So in the end our variable is going to be t. It's just that people don't like it, and formally maybe it doesn't really make sense to have t's in here and in the limit. So we write it this way. But we're not doing anything crazy here. So this would be -3/5 e to the -5 tau, if I did that antiderivative correctly. And then I put in 0 and t, so I would get -3/5 e to the -5 t. And e to the 0 is 1, so then I'll just write +3/5. And that is the inverse Laplace transform of what we started with, without partial fractions. So let's do another one. This one. 1 over s squared times s squared plus 1. So I'm going to start the same, well, right, okay. I've got s squared in the bottom. I could take one of the s's off, because what did I do last time? I took the s off, and then I found the inverse Laplace transform of that, and then that led me to know how to do the inverse Laplace transform now that I put the s back. So if I'm going to take an s off, I have to know how to do the Laplace transform of what's left after I take the s off. Unfortunately, here I've got s squared, and if I take an s off, I'm still going to have an s there, and I would not know how to do the Laplace transform of that. However, I can just do this twice. I'm going to take both the s's off. I'm going to find this Laplace transform. And then after this, I'll find the inverse Laplace transform with just one of the s's there. And then finally, I'll find the inverse Laplace transform with both of the s's there. Okay, so here I go. This one, this is either sine or cosine. I was just bragging about how much I remember, and now I forget. So sine is the one without any s's on top. So this and so this looks like k is 1. I get 1 over s squared plus 1. So this is sine t. Okay, now inverse Laplace transform. If I put an s there, is the integral from 0 to t of that, except it's all tau's inside the integral. And this is no problem. This is negative cosine tau 0 to t, like that. So negative cosine t. Cosine of 0 is 1, so plus 1. Yeah. And now, like I said, I'm just going to do it again. I can put another s in the denominator. And if you see what I'm doing, every time, like to get from here to here, I did the integral from 0 to t of this. Now to get from here to here, I'm going to do the integral from 0 to t of this. Oops. Tau. And that's whatever it is. Oops. Negative sine tau plus tau. Like that. So negative sine t plus t. And then when I put in 0, it looks like everything's 0. Sine of 0 is 0. This is 0. So it's just that. Okay, so then I think that's it for 10.2.